Hello students, it says find the set of values of k for which this equation has distinct real roots. Now, we'll compare it with the standard quadratic equation of ax squared plus bx plus c. So the value of a that we got is 2. So the value of b that we got is 3k. And the value of c that we have is k here. Now, we'll apply the discriminant formula that b squared minus 4ac should be greater than 0. So the value of b squared is 3k whole square minus 4 into a. So the value of a is 2 and c is k, has to be greater than 0. So we got it as 9k squared minus 8k should be greater than 0. So if I put 9k squared minus 8k equal to 0, so I'll get two points or two critical points to check for the value of k. So one is k equals to 0 and the other one will be k equals to 8 by 9. So I'll take up a value which is, if I'm talking about k equals to 0, so I'll take up a value which is less than k. So if I take k as equals to minus 1, and if I place that value into the original equation, so yes, I see that it's greater than 0. So since the value of k equals to minus 1 is less than 0, so all values of k less than 0 will satisfy the given inequality. Similarly, I'll check for the other point, which is k equals to 8 by 9, and I'll take up a value which is greater than 8.9. Say I'll take k as 1. So if I place k as 1 over here, so definitely I can see that 9 minus 8 is 1, which is true, is greater than 0. So that means all the values of k greater than 8 by 9 will satisfy this particular inequality. So these two will be the valid answers for this question. Thank you, students.